before we get started, I want to ask you guys about the team. How's the team going? Who has formed teams? Do you remember by what time you're supposed to submit it today? 5 p.m. If you don't know, I think I only have received around 5 teams. So if you don't know, you can find the submission form under the project folder, and you click this one, you'll be able to submit your team information. All right? So today after 5 p.m., if you're not in any team, we will help you to form your team. All right? So that's for the team. Next thing, I want to introduce you guys to our TA, Yanjun Gao, and I'll let her introduce herself.
Hi, my name is Yanjun, or you could call me Serena, and I'm second year PhD in computer science and engineering. And my job is mainly to help you guys design the database and give you some suggestion, because I have a lot experience about how to design an application with the database. And also my job is to grade your homework and hold the office hour. I think the office hour will be Tuesday and Thursday. Yeah, it's on the screen. And so, welcome.
Okay. Yeah, so if you have any questions, doesn't matter if it's homework or is it relating to the project, you can go to your office hour. Also my office hour, but mine is kind of early. All right. Then, before we move on to the lecture, remember I said we would talk about the projects a little bit today, okay? So, who has read the project description? Awesome. 3, I guess. Okay, so you still need to read through this, okay? It's not super long, but you know I put in effort to write it, so I really appreciate if you can absorb it. So what I will mainly focus on today will be talking about phase 1. Yeah, let me see. A bit on overall, all of the phases that the rules apply. You guys will need to, let me see. You guys will need to format the document following a template that I provide. You can find that from here. And also under the project folder, we have the project report template. You can download it. It will kind of look like this. It's like the most plain possible template, but it has everything that you will need to include. So you have to start with the table of contents, okay? And you will have to start with a list of figures and a list of tables. All right? These are all required. Then you'll move on, give your introduction. Let me see. And here I will tell you some of the format guidelines. Also, for the figures, you will need to put captions on it. Okay? Do you guys know, like, for figures, the captions have to be below, but for tables, the captions have to be above. Okay? These are just rules. Also, don't forget the page numbers, all right? And also, you are very encouraged to include a lot of dependencies. For example, you have some screenshots that you want to share, or you already started writing some codes, there are some snippets that you want to share, and you can put them all in the appendix. Okay? Also, for the appendix, 2 really important parts. One is the GitHub repository that you can generate some of the status from it. Okay? So you can give me some screenshots of the status showing me who commits more, who contributes more. Also, you will need to provide the Asana project progress. Okay? So you guys can play around with Asana and see how you want to finally export the information and then show it to us to see how you organize the task and how each one of you take care of the tasks. Okay? So one thing about the page limit, for phase 1, you will need to give me a report that's no less than 15 pages. All right? Sounds like a lot, but actually not that much. And for phase 2, you will give me 25 pages at least, but it will be based on phase 1. Okay, so it's not like the next time you get a whole new 25 pages. It's based on that phase 1, you will correct some of the errors, or we will give a suggestion, you do some modification, then you move on to phase 2 in total will be 25 pages, and phase 3 will have 35 pages. Okay? So for the pages, don't forget they won't include the appendix and also the table of contents. So the actual contents itself has to be no less than these page numbers. Okay. Okay. Let's move on to phase 1. Okay. So for each phase, I will give you this little to-do list that you can remind yourself. Don't forget to do some of the tasks. So for phase 1, two really important tasks. One is called requirement analysis. Before I get in here, let me just go to the slides for today. Okay, so we have different phases in our database application design, and in general we have these 6. And for phase 1, you will do the requirement analysis and conceptual database design. Okay, these 2 are getting to later. And for phase 2, we will do logical database design and schema refinement. In terms of physical database design and application and security design, you don't have to worry about it. In some other words, you don't really have to worry about how secure your final project is. Okay, the last 2, we won't get in there. So the first 2 will be for phase 1, the 3 and 4 for phase 2. So what is requirement analysis? So imagine you are hired as a database application developer. Your customer will write a statement of objectives telling you what the customer wants, what they expect to get from you, and what the application is supposed to do. Okay? So you will get the statement of objectives. The people providing you with the statement of objectives, they don't really have any background of database design, right? So you will be the one, based on the statement of objectives, write a requirement document. Okay? So for phase 1, one of the most important tasks for you is to write the requirement documents. How to write the requirement documents? You will expand from the statement, a statement of objectives, and describe what the system is supposed to do, but not yet how to do it. Okay? So for phase 1, you don't have to worry about which database you're going to choose, which programming language you're going to use, or what tools in specific that you will finally use to code your application. Just think about how you want to achieve. Okay? So for the documents, I provide you with 11 basic functions that you're supposed to include all of them into your final product. So all of them already have some descriptions, but your job is not to copy this into your documents, but based on these, describe a bit more if you found that there's anything a bit vague that you think it needs to be clarified, okay? You list all the 11 functions and then talk about, oh, and also I think this will make the function better, but not in a very technical way, okay? So as you can see, if you don't know, your project will be working on an online shop, okay? Where it's like a combination of Amazon and eBay. Okay, you can either directly buy a product or you can bid a product. So, of course, if it's an online shop, we will have items, which are the products, right? Found someone upset. Wait, give me 1 second. So I'll just talk through this, but you don't have to worry if you don't want to make online shop, okay? But this is like the framework that your project has to fall into. Also, you will have to design registered users. So users are supposed to be able to enter your website and be able to create an account. Also, users can either rate each other. For example, the buyer rate the seller, seller rate the buyer, and also rate the product. Okay? However you design it, you can make it a 5-star rating system or anything. Also, you will have to let the user being able to browse through your application. For example, when you go to Amazon, you can click on the left-hand side. They have like a category trees, right? You have to click through it, so you should be able to let the user do that. And also for searching, you will have a search bar. Okay. Okay, all these things you can look through. So these are the 11 functions. So besides the 11 functions, I would expect you to also design 2 extra functions based on this, however you want it. I won't give you a hint now, otherwise you just do that. But you can think of whatever, like you think this is lacking or you think it would be fancy to implement. If you want to implement more than 2, that's fine. Okay, just provide it into your documents, saying, oh, these are the extras that I want to do. Okay? So, as I said earlier, you don't have to make an online shop. If you think of anything else that can still interpret these functions into your application, you can do that. But you have to make sure all the 11 functions are included into your application. So in previous years, there were students making, let me see, instead of making an online shop, they make like a freelancer hiring website. So users can be a freelancer or an employer, and they can, the product will be the project that they try to make it for the employers. Or other people, let me think. Other teams, they also implement like a library system. Okay, so people can borrow the book, or you can donate the book or something, and there will be administrator rating whether the user returned the book late, anything like that. Other thoughts, you can look through whatever that's online. Some people will implement something. I remember they implemented something really similar to Kickstarter. Also, one team, they implemented a Facebook duplicates. That's pretty awesome. And they let the user being able to chat with each other and those kind of things. Okay? So that's the expectation. You can do whatever you want, but just make sure that you can interpret the functions to your own application. Okay? Also, if you want to do an online shop, don't really worry about the lame name. So you can name whatever you want, okay? I just don't know what the name is. I just name Hello World. Okay, so that's for task 1. Any question regarding to task 1? Okay, let's move on to task 2. So task 2, it's called the conceptual design. And that will be on what you're learning right now, the ER model. Okay, so after you do your requirement analysis, you will have a clear idea how your design should be, and then you want to draw them out into the ER diagram. Okay. Later on in today's lecture and the next week's lecture, you will learn a lot more about ER model. Then you will incorporate those things into your diagram. Okay. And as I underline right here, please do not assume the underlying database system. So right now, don't really worry about what you're going to choose later on, if it might SQL or NoSQL, anything like that. Just don't worry about it, but then follow whatever you learn right now to do it. Okay? I think that would be it. Let me see. Okay. A little bit more. So it's due September 18th. On September 18th, not only will you turn in the project report in hard copies, also electronically, Angel. So for hard copies, I would expect you to bind it well. So if you turn out to have a lot of pages and you can't staple it, find some other way. Okay, clip it or anything like that. Also, you will be giving presentation in class. It's going to be relatively short because I would expect we'll have around, let me think, we have 60 people and each team has no more than 5, so like 12 to 15 teams around that. So because we have a lot of teams and we want to do it in class time, so every team should limit the time in 5 minutes. Okay? So you will come up here and do the presentation. You will be recorded, which is nice. And you will talk about, I think I list the presentation content on the website, so you can take a look at what you're supposed to include into your presentation. And I would expect you to rehearse with your teammates, or I don't really mind, does it have to be one person presenting or all team come up? I know some other classes, like all the team has to take turn, all team members has to take turn or something. If you want just one member presenting, that's totally fine. Okay. That will be it. Any other questions? Okay. If there's no other question, do you guys know what day today would be? Quiz day. Okay. So I'll give you 5 minutes. I think it's really easy to pay attention to that. Okay. Ready? No problem. Like that. I know what I'm doing. Oh, it's okay. Okay, give you 5 minutes. Who needs more time? All right. If you're done, pass it to the front. this should be posted really fast. Just so you know, answering everything right is better than making mistakes, but making mistakes is better than not coming here. Okay? So even if you answer everything wrong, you're still gonna get points because you're here. Okay. Now let's move on and review from the end of last time. Okay? So last time we ended up talking about the ER model basics, right? And we said entity is the real-world object distinguishable from other objects. Okay? And entities, they have attributes. So right here we have an employee as the entity, and employees will have the attributes of social security number, name, or lot. And also we talked about entity set. So an entity set is a collection of similar entities, for example, all of the employees. Right? So just don't get confused when we talk about just a single student. The student is an entity. And when we have all of the students, because all the students share the same attributes, even though the values are different, they form an entity set. Okay? So we said entity set is a collection of similar entities in the sense that the entities share same attributes. Okay? Also, last time we ended talking about entity set has the key. So key is the minimal set of attributes whose value uniquely identify an entity, right? And I asked you guys how to, what it will be ideal key for a student, and you guys told me the student ID will be a great choice, okay? How about in other scenarios, do you think there's always just one attribute that's suitable for serving as a key? Or maybe there are different attributes, they can all be unique, okay? So for all these attributes that can serve as key, we will call them the candidate key. Okay? So they're like good candidates to be the key. Okay? But in the database, would you want to have so many attributes to serve as keys, or eventually you would just pick one? You would just pick one. So that would be called the primary key. Okay? So, out of all the candidate keys, whichever that you're going to pick as the primary key really depends on different kind of application. Okay? So you will be the one, if you're designing it, you'll be the one choosing. I think this is better for being a primary key for different kind of reasons. Okay? Maybe when searching, it's easier because you can just hash it or something, then it's easier to get that key to retrieve the information you want. Okay? So, let's talk about the attributes. Do you guys think for attributes, for example, let me see. For example, a student in a course received a grade. Do you think the grade can be like whatever values? Right? It has to be like a rules, a limitation, right? So, for a set of primitive values, we call it the domain. Okay, each attribute has a domain. Okay, so let's elaborate a little bit more on what we mean by entity set and entity. Okay, so each of this, like this is the customer entity set, and each row in it is an entity. Okay, and right here we have a whole lone entity set. Each of them is a lone entity. Okay? And because they're in the same entity set, they all share the same attributes. Okay, this is pretty straightforward. Okay, so before we move on, if entity have entity sets, how about relationships? Do you guys think they will also have relationship sets? Sort of, maybe? Okay, so relationship is the association among two or more entities, right? I think in the first lecture we talked about you as a student entity, your relationship with this course is that you're taking this course. Okay? So all of you will be taking different kind of courses, right? And you will have so many relationships with different courses. So that would be relationship set. Okay? It's a collection of similar relationships because both sides have the same entity sets. Okay? When we talk about relationship, it actually does not have to be just involving two entities. It's possible that it can involve more than two entities. Okay? For example, we can have you as a student working on a project advised by a professor. And that would involve three entities, right? So the N right here does not have to be just two. Okay? Sometimes it actually can only be one, which I'll talk about later. So for entity sets, whenever we want to denote it, we denote it as uppercase E1 or En, okay? E1, E2, En. So for a relationship set, it gets a little bit more complicated. Okay. If we have a relationship set and it involves n entity sets, n entities, then we have E1 all the way to En, which E1 is from entity set 1, right? E2 is from entity set 2. Does that make sense? So, do you guys think for the same entity set, it can participate in different relationship sets or not? Yes or no?
Yes.
Yeah. Okay, so you can say can or could. Let's give you an example. Let me see whether it's this one. Not yet. Okay, I'll show you an example later. Okay, so a relationship can also have descriptive attributes. So not only entities can have attributes, relationship can also have attributes. For example, you taking this course, we can have the relationship has an attribute of which semester you're taking this one. Okay, so it records the information about the relationship rather than any participating entities. So what do you think when we want to identify a unique relationship? What can we rely on to identify it? Do you think relationships will have IDs?
No.
Then how will we identify the relationship?
From the key of the entities who are taking part.
Exactly. So to identify the relationship, we rely on the participating entities. Okay? We don't design like extra IDs for relationships because both entities will already have their own unique primary keys, right? And we just need to use that to identify the relationship. Okay? So here will be an example of creating a relationship. So here I just put two separate entities, entity set. If we want to create a relationship between them, so we know like entity sets we use rectangles and the attributes we use oval. For relationships, we use this, what's it called, diamond. Okay, so you draw that, and it means there's a relationship between employees and departments called employees working in a department. And I said, as I said earlier, because relationship, they can have attributes. So if you just draw that, that will give you an attribute for the relationship. Okay? And it can include more than that. So I think I didn't mention it before, but someone else mentioned it maybe last lecture. If an attribute is the primary key, you will underline it. Okay? Then saying, for example, for an employee, the primary key to identify the employee is the social security number. underline that. And for the departments, maybe every department has their own ID, underline that. And note that in the relationship, we don't underline any attributes. Okay? So that would be it. So here would be an instance of the work scene relationship. Okay? For example, here we list, let's say we have a tiny database in which we only have 4 employees, okay, and we only have 3 departments. And we list all of the employee ID in here, and all the department's ID right there, and here are the time they start working in the department, okay? So you can just link from the employee to the working time, and then to the departments, okay? Do you notice any relationship, like any connection between the employees and departments? Are there any constraints? Like maybe the employees can only work for one department?
Like more than one.
Yeah, an employee, as you can see from this one, it can work for more than one department, right? And also for a department, you have more than one employee, okay? So for this kind of instance when we have no constraints, let me see whether I have, we call it many-to-many. Okay. Also for the employee parts, do you see any employee that's left out, like in the database not working for any department? No. Also for the departments, there's no department, no one working there, right? So if this is what's happening in your data, we call the employees the total participation, and the departments also total participation. So all of them has to be involved into the work scene relationship. All right, so as we talked about earlier, when we talk about attributes, we sort of just view the attributes as single values, right? But do you think for attributes it can always be single value? Or sometimes the attribute itself has some kind of structure? Let's take this as an example. So for example, a person's name, and it might involve the first name, middle name, and last name. Or other example can be for an address, right? It will involve the street, or what, apartment number, city, state, and zip code, this kind of thing, right? So when we have this kind of structure for the attributes, what do you think? How can we handle that in the ER model? Based on what we have learned. We can change name into what? If name now looks like an attribute, we can change it into another relationship. We can use an entity. Okay? So let me see whether I have that. Yeah. So what do I mean by using entities to service the attributes? For example, right here we have the ER diagram from earlier, right? Employees working a department. Let's say we want to add the information of which city or which location it's working in. Then you can use that, okay? So location now we can kind of consider it as the, one of the attributes for works in, but then location also includes different attributes. Make sense? So instead of having location as just one single attribute that's for works in, you can actually expand that so that location can include information for address and capacity. Okay, but when you look at it again, it doesn't seem like location looks like an attribute anymore, right? It looks more like works in the relationship itself involves 3 entities, right? So for this kind of relationship, we call it ternary. As I said earlier, the relationship don't have to just include 2 entity sets. Another example, as I said earlier, it's possible a relationship can only involve 1 entity set. For example, there will be relationship between the employees, right? Just between the employees. For example, some employees might be the superior for another employee, some employee work for another employee. So then we will have, let's say, all the relationship, the same relationship happens all just among the employees. We can actually have a relationship that's like this, okay? So maybe one employee is a subordinate of another one and reports to the supervisor of another employee. So just as a hint, in your project, you'll be designing the categories for your products or whatever items that you have. So in that case, you will have every category as an entity, and then it can be a subcategory of another one. And that will be a very similar concept as this, right? For example, if you go to Amazon, then you click on smartphone, then a subcategory might be iPhones, right? This kind of thing. So you can borrow the idea right here to design your categories. Okay. Any questions so far? All right. So this, even myself makes the mistakes all the time. I say relationship is relation is relationship. Okay. So just so you don't confuse between them, relation, as we said before, is a set of tuples, and which is the table that we saw, I think, last lecture and the first lecture. A relationship are what's between the entities. Okay. And just to note that both entity sets and relationship sets, we can represent them as relation. In other words, both can be represented as tables when we store the data. Okay. Can you imagine the relationships being stored as tables? Okay. Okay. So up until now, we haven't talked about any kind of specific constraints when we have relationships. But a lot of times we do have constraints. For example, maybe one department can only have a dean, right? One dean, you don't have multiple deans. Or for, let me see. This is not always true, but for one course, maybe a lot of times it can only be taught by one instructor. So for this kind of constraints, we call it the key constraints. Okay? So as we saw before, this kind of ER diagram, we don't have any constraints for it, so you can interpret it as an employee can work in many departments. Also, a department can have many employees, right? So when you see this kind of lines that doesn't have anything else, just lines, then that's many to many, okay? But today, let's say we want to add some more constraints, okay? If we are talking about a managed relationship, and you say each department has at most one manager, okay? Then what you're supposed to do when you design the ER diagram is you just draw a tiny arrow right there, okay? Here, from departments pointing to managers. So you want to kind of be careful of the direction of the arrows because it's kind of like conventions of the ER diagram design. How about if I take that out and we only point from employees to managers? Then what would it mean? Yeah.
There's one person that's managing all the departments.
Close. It's a person can manage at most one department. So here we have the departments can only be managed by at most one person, right? But if we go the other way around, if we have the arrow right here and not here, then it will mean a person, an employee, can only manage at most one department. Does that make sense? Okay, let's think about it a bit more. If we have 2 arrows for both sides, what will it mean?
One manager, one department.
Hmm?
It has to be like, for one department, there has to be one manager. And each one of the employees will be manager.
Oh, that would be another constraint. So you're saying like at least one, like exactly one.
Exactly.
Oh, that would be another. So this is for upper bracket. Yeah. So if we have from both sides, both arrows, what does it mean?
At most, one manager per department, and at most, an employee can only manage one department.
Yeah, exactly. So when you're designing your project, you will use a lot of this kind of key constraint concept. Okay? So now we have 4 possibility. Your job is to draw here, okay, the arrows. So let's start from here. What will happen for the one-to-one? As we just discussed. What happens to the arrows?
No arrows.
Mm-mm. Both arrows. Okay? So if it's one-to-one, then both entities point to the relationship. Okay? How about if it's many-to-one? Saying like, let me see, I forgot which one is it. Okay, so it means, okay, here is the employee and here's the department, right? And one employee can only work for at most one department, but there's no any constraint right here. So one department can be managed by more than one employee. So then, if we know that one, the next one is easy. You just have to flip it around, right? So if it's one to many, then that's like this. So, as we can see, here is the employee, here is the department. A employee can manage more than one department, right? Like this one, it manage more than one. But for one department, it can only manage by one. Last one, easiest. What should we do for many to many? Yeah, do nothing. Okay, so for many to many, keep it simple, no arrows. Okay, so that's for the key constraint. Before we end today's lecture, I want you to use what you have learned so far. Let me see. Wait. Let's skip this, it's easy. I want you to use what you have learned so far to draw an ER diagram that satisfy the 7 requirements. Okay? You can discuss with your classmates sitting next to you, and I'll show you how it looks like after you guys think you're done. and I'll give you 2 more minutes. Okay? Who wants more time? Okay, 1 more minute. Ready? Okay, I'll show you the answer. Okay, it looks like this. So we have 2 entity sets, right? One is the factory, one is the product, right? And factories produce product, right? And as the requirements, the factory will have an ID, like a unique ID that you can identify the factory. So you can put whatever, like factory ID or FID. Okay? And factory also have, let me see, the city. Products have product ID and color. Right? And also, yeah, I made this not realistic at all. So a factory can produce at most 1 product, and a product can, oh, this one I made it wrong. So a product can be made by only 1 factory. Change my requirement to can only made by at most 1 factory. Okay, if it's only exact 1, that will be the constraint I'll talk about next time. Sorry about that. Okay, and also here for the very last requirement I have, a factory can produce a fixed quantity of each product. So then you put the produce relationship with a quantity attribute. Okay, and don't forget the direction. Be careful of that. Yeah. What? Oh yeah. So I'll say it again. Change the number 6, requirement 6, to a product can be made by at most 1 factory. Okay, instead of only 1. So if it's only 1, I'll talk about it next time. Before we end the lecture, just a few things. So remind me to talk about the slides I skipped. Yeah. First requirement. Each factory has a unique ID. Oh yeah, because it doesn't matter. Because city does not have to be unique. The city will not be used to identify the factory. So different factories can have same city. Okay, so that's just kind of a tricky requirement. Okay, before I end, I already post homework 1, and it's due in 2 weeks. Okay, so some of the stuff in homework 1 you have not yet learned, but then you will learn it next week. Okay, so don't forget to submit your team by today 5 p.m. All right, see you on Monday.